Good morning.
Good morning, sir.
Good morning to all.
Good morning, sir.
Yeah, good morning. So we have done some numericals on gas expansion of gases yesterday. So today we will see that quill tube, and then we can go for transmission of heat students today. Quill tube. So so this is the why quill tube means. So quill tube is used to verify the Boyle's law. What is the Boyle's law? The product of pressure and volume is constant when temperature T is when T is constant. Okay. So therefore, product of pressure and volume is constant when temperature is constant. So then if you prove that T equal constant in places, then Boyle's law is verified. For that, this is a quill tube is one of the operators. Okay. So then this is a cylindrical glass tube, capillary tube. Cylindrical glass capillary tube, so that one of the end is opened, one of the end is closed. Mercury column is introduced in this cylindrical capillary tube, and some air is trapped below the mercury pallet under or in between the mercury column and this closed end. So this is about how to prove this means PV equal to constant. No? So then the PV is equal to constant means have a look on it. Volume can be written as what? Volume can be written as P into volume equals to I can write area into length that is equals to constant. So therefore anyway, for example, what is mean by this is the nothing but L we can write. L is nothing but what we can write length of air column. Okay, length of an air column. So anyway, area of this constant means what is the volume of this air column? This length of the air column into area of the capillary tube A. Anyway, A is constant. Depending upon this, if the mercury parity is moved up, means this length is increases. If the mercury parity is moved down, means this length is decreases. When L is increasing means volume of the air column is increasing. When L is decreasing means volume of the air column is decreases. L is variable but area is constant. Area of the capillary tube does not change. So that's why if A is taken that side, then P into L is equal to constant by area. Constant by constant causes another constant. So anyway, product of P into L is equal to constant. So by using this, we can verify the Boyle's law. Before going to the, this quill tube, two formulas we should remember that the pressure P is equal to what we can write force by area. That is already you know that the pressure P equal to force acting per unit area normal to it surface, that is known as the pressure. From this one, what we can write that force F is equals to pressure into area. Force F is equals to pressure into area. And what is the fluid atmospheric pressure means okay, atmospheric pressure We can write P naught that's equals to rho density of rho G H. So what is mean by rho? Rho is nothing but density of mercury. Density of mercury. H is nothing but height of mercury column. Height of the mercury column. So by using this, already we noticed that. And one more thing, in what direction? For example, here. Okay. So here I am tracking at this point. Atmospheric pressure means in what direction it is acting? In all directions. In all directions. For example, here this is the point. Atmospheric pressure is P naught means in what direction the P naught? In this direction P naught, in this direction P naught, in this direction, in this direction, in this direction. In all possible direction the pressure is P naught. That is one of the characteristics of the fluid pressure. Pressure is acting in all directions. For example, if I take a bucket of water, okay, bucket of water. So here I have considered a small point which was at a small h below. What is the pressure at this point? Means pressure at this point is pressure due to this water column of height h, and above that there is an atmospheric pressure is there P naught. The total pressure at the point P, this point is pressure due to the atmosphere P naught and pressure due to this water column H. In what direction that pressure is acting means in all direction. In this direction, in this direction, in this direction, in this direction, in all possible directions, pressure is acting there. Don't say that the fluid pressure, for example, here atmosphere, this open end of the mercury is exposed to the atmosphere. Atmospheric pressure is P naught means in what direction that P naught is acting. P naught is acting vertically downward, vertically upward, horizontally left hand side slantways up, slantways, and in all possible directions it is P naught. Okay. That is the characteristics of the fluid pressure. Soon you will get in the chapter called mechanical properties of fluid. Till then remember that fluid pressure at a point in a fluid acts equally in all directions. We can't say that exactly vertically downward, vertically up, in all possible directions. For example, here if you take the point, at that point acting downward direction. Here if I take the point, it is acting slantwise this direction. So pressure is always normal to the point where we have considered that. So that is about field tube. Let us see different cases of the field tube and how we can prove the Boyle's law also. So what is mean by field tube means field tube is a glass capillary tube which was fixed to the meter scale. Okay, so this is fixed to the meter scale to measure the length of this air column. What was there inside means one end is open and is there, other end is closed. Mercury column is introduced in the glass capillary tube so that some air is trapped between the mercury column and the closed end. That length of the air column is small L, so by the displacement of the mercury column, the length of the air column may changes. According to Boyle's law, product of pressure and volume is constant and the temperature is kept constant. So therefore, PV equal to constant. PV equal to constant means product of pressure into area and length. So here, when this mercury column is moved up, means the length of this air track, the air column is increases, and if the mercury column is moved downward direction, the length of the air column is decreases. So therefore, P into L equal constant. Here A is taken this side, constant by constant causes another constant. That's why we wrote constant here. P into A L is equal to constant. Okay, so we can write this. Then we can go for different cases of video. If you finish this gases is completed, then we can go for heat transfer. Make it fast. Okay. Okay. Finish. So first listen carefully. Okay, four different cases we'll see that. Then at last, okay, then you can copy the overall. So then first case one. Okay, case one. So what is the case
Sir, it's
one?
not visible. Now
Case,
visible.
yeah. So listen carefully, and you can write students. Okay. First, listen, that you can write. So this is the open end. I'm taking about this thing. Open end is kept upward direction. Open end is kept upward direction. So this is the mercury column. Okay. So let here this side is exposure to the atmosphere means like this is the P naught is an atmospheric pressure, and some air is trapped. Some air is trapped between the mercury column between the mercury column and this closed end means that air is having some pressure. Let us say this is the pressure P1. What are the forces that are acting means on the mercury planet? Listen carefully. Listen. So first one is because of this pressure P naught, some force is acting downward direction. What is that force means P naught into A? We know that pressure P is equals to F by A, then F is equals to P into A. Here this side is exposed to the atmosphere. That's why P naught is the atmospheric pressure means because of this P naught pressure on this surface, what is the force that is acting means P naught A force is acting downward direction because of this atmospheric pressure. Similarly, this side the pressure of the air which was trapped inside is P1 I told you because of this pressure P1 a force that is acting upward direction that is P1 into A. And in addition to that, the mass of the mercury pallet that is acting downward direction. Is there any other forces are there? I have listed all the forces. What are the forces that are acting on the mercury pallet means this side of the mercury is exposed to the atmosphere because of the atmospheric pressure P naught of capillary tube of area A. A force say F is equal to P into A. Here pressure is P naught into A. That force is acting downward direction. And here some air is trapped below the mercury column, mercury pallet. There the pressure is, let us say P1 is the pressure. Because of the pressure P1, this mercury pallet will experience a force P1A in all directions. As I told that the pressure is P1 means in all directions it is P. So above this point there is a mercury pallet is there. That's why mercury pallet will experience an upward force because of the pressure P1. And above the mercury pallet, the pressure is P naught. Because of the pressure P naught, the mercury pallet will experience a downward force. And the weight of the mercury pallet is gravity is always acting downward direction. If I draw a free body diagram, what are the forces that are acting downward? P naught A force is acting downward direction. Its weight mg is acting downward direction. and this is P1A is acting upward direction. Let us say this is L1 is the left of the mercury column. Then if the mercury pallet is either not moving downward direction, either it is not moving upward direction, means then the total upward force must be equal to total downward force. You have studied that in Newton's laws of motion equilibrium condition. What is the force that is acting upward direction? Means this is the force. P1A force is acting upward direction. Downward force that is equals to this mg, and this P0A is acting downward direction. Then we can write P1A is equals to mg plus P0 into A. So let it be P1A is equals to mass can be written as what? Mass is equal to density into volume. Density into volume means area into length. So what is the length of the mercury column means H. Now then I can write A H into G plus this rho naught value already we got rho G H. Rho G H into A. So A is common among all the term, it gets cancelled. So then P1 that's equal to what can I write? Rho G is common among this, then I can write H plus capital H into rho G. So this is here it is. Then according to, so let us see this, let us see last one. So this is about the case I understood this case. Students, is there any doubt on why this P1A, P0A is acting downward direction, P1A is acting upward direction? Is there any doubt, students? Online?
No, sir.
Clear?
Sir, how you written that equation? Can you explain, sir, again? P1A is equal to mg into mg plus P0A. How you wrote? Can you tell, sir?
List out what are the forces that are acting on mercury planet. One force that is due to P0 is acting downward direction, and its weight is acting downward direction, and force due to the pressure P1 which was trapped inside the trap here that is acting upward direction. Just I have represented this system as a point mass, and I have drawn the lines. This is an upward force, this is the downward force. What are the net upward force must be equal to net downward force because of the turbo.
Okay, sir, understood.
Okay, so right next coming to case 2. Okay, that we can write on listen first. Okay, 4 cases we will see, then we can write last. Listen. Okay, so case 3. In this case, let the pressure is here is P2. Anyway, this is exposed to the atmosphere. Let it be the pressure is P0. Okay, and here length of an air column is let us say L2. Okay, one by L1 like this. It might be L2. So then here, what are the forces that are acting on means because of the pressure P0, the force that is acting upward direction is P0 into A. Because of the pressure P2, a force say P2 into A is acting downward direction, and its weight mg is acting downward direction. Again, if you draw the free body diagram, what are the forces that are acting upward means upward force is nothing but P0 into A. Downward force is nothing but mg, and in addition to that, P2A is also acting downward direction. So then, when the equilibrium means equating all the forces, then what can I write? P0A is equals to P2A plus mg, and this mg is taken this side, then P2A is equals to, we can write P2A is equals to P0A plus minus mg. Okay, so that implies P2A is equals to what can I write? P2A equals to P0 means rho G H into A minus m means already we got mass is equal to density into volume means density into area into height. So therefore density means rho into area is A H G So therefore, A gets cancelled. Then we can write P2, that's equals what can I write? H minus small h into rho g. I can write H minus small h into rho g. We can write. Okay. Next to case 3, let us see case 3. Okay, case 3. What are the forces that are acting means here let L3 is the length of an air column. I will take L3 and the pressure is P3 and this end is anyway exposed to the atmosphere, then I can write P naught. Then I can write P naught. What are the forces that are acting means because of the pressure P naught, it will experience a force towards like this with P naught here. Because of the pressure P3, it will experience a force towards like this, that is P3. Got it? Why this force is acting? I told you that pressure is acting in all direction. Here the pressure is P3 means in upward direction P3, downward direction slantwise this side, horizontally this side, left side, right side. In all direction the pressure is P3. Because of this P3 pressure, this whole mercury pallet will experience a force pressure into area of the mercury pallet. Similarly, here P naught in all direction it is P naught only, fluid pressure characteristic that is. Because of the pressure P naught, this side of the mercury will experience P naught a flows towards like this. And its weight is acting downward direction mg. So when weight is acting downward direction means the mercury column, this glass tube will experience a reaction force that is called normal reaction and is acting upward direction. Clear? So then, if you draw the free body diagram for this case, what are the forces that are acting means? So because of P3A, this is acting P3A this side, and here that is acting P0A is acting this side, and here it is the normal reaction force, and here it is mg is acting downward direction. So if it is not going means n must be equals to mg. And here P3A must be equals to P0A. A gets cancelled. Then P3 that's equals to rho G. So that is about this is our equation number 2. This is our equation number 1, and this is our equation number P3. This is P3 is equals to equation number 6. This is about case 3. Okay, listen carefully. Case 3. Now we can go for. Case 4, let us see this case 4. Okay. Case 4, last case. So if the tube was kept like this, then on such case, same area A, which was inclined an angle theta with the vertical. So then in this case, what will be happen? List out what are the forces that are acting on it. So here it is P4. Let L4 is the length of air column. This is exposed to the atmosphere. This is P naught only. Okay, now what are the forces that are acting on? Weight is acting downward direction only. Weight is acting downward direction. So then angles we want. Just a minute. Resolving into these two components. This is one of the component. This is one of the component. Here it is inclined an angle theta. Inclined an angle theta. So then this is also theta. Yes. Just a second. What are the forces that are acting means here because of the pressure P naught? A force say P naught A is acting towards like this, and because of this, a force say P4A is acting up. Weight is acting downward direction. I think you know that how to resolve the weights. So resolve the weights. This is an angle theta. This is an angle theta means so then how can we write this is here is the angle. So with this is an angle theta. Okay. So then this must be also this is an angle theta means this is also angle theta only. This is a theta. This is a theta. So this will be theta. Here, identify the angle between them. This is an angle theta. So then, incline an angle theta with vertical means perpendicular. Also, we can't. So this is the line. So, this is an angle theta means then this will be also the angle theta. This is theta. Yeah. This is also theta. The horizontal. This is yeah, so this will be theta. This is the theta. Got it? This is also angle theta. How I can got it means observe clearly. This is an angle theta means this is also the theta only. Isn't it? This is also theta. This is also theta means what is this rest of angle? This rest of angle will be 90 minus.
90 minus theta.
So this is 90 minus theta means this is also 90 minus theta. So then this is 90 minus theta means this will be theta. So then if I resolve this, the mg means this will be nothing but what? Mg cos theta, and this will be component mg
Sin theta.
theta, and here is the normal reaction force n is acting upward direction. And if you draw a free body diagram, what are the forces that are acting means P naught A force is acting towards like this, and the component that is nothing but mg cos theta is acting towards like this, and P4A is acting towards like this, and mg sin theta is acting towards like this. Similarly, normal reaction n is acting towards like this. So then these are the equilibrium forces. Hence, these two are equated. The reaction force by the walls of the glass capillary tube is balances this mg sin theta, and this P naught A mg cos theta will balances this P4 means I can write it here. P4A is equals to I can write mg cos theta plus P naught A. Substituted this P4A is equals to what we can write P4A is equals to mg cos theta means already we got m equals to mass equal to density into volume, then we can write rho A G H cos theta plus rho A G H. This A they gets cancelled, then P4 that's equal to capital H plus small h cos theta into rho G. Here length of an air column we have taken that length of an air column we have taken that is L4. So therefore, I got the relation. No? So pressure in the first case of the pressure of the air column, which was trapped here, that's equals to H plus H into rho g. In the second case, the pressure is P2. That P2 is equal to H minus H into rho g, and the pressure P3 that's equals to here. The pressure which was trapped here. The pressure equals to rho g h. The pressure when the capital Q is kept like this, the pressure is so then, according to Boyle's law, what is according to Boyle's law? We can write observe clearly. Okay. So just it was at last one. So this is. So from this relation, what we can write from Boyle's law? What I can write from Boyle's law? Observe clearly. You know? From Boyle's law, we can write it. Okay. So here I am writing. Have a look on it. So P into L is equals to constant. So therefore P1 L1 is equals to P2 L2. That is equals to P3 L3. That is equals to P4 L4. What is the P1 means? P1 means H plus capital H into rho G of L1. Are you getting it? Plus P2 means that is H minus small h rho g into L2. Okay, so that's equals to what can I write? P3 means P3 that's equals to we got rho g h into L4. That's equals to we got P4 means H plus
Rho g h into L3.
huh?
Rho g h into L3, sir.
Yes. L3, okay, L3. H plus H cos theta into H plus H cos theta, we can write it here. So H plus H cos theta into rho G L4 I can write. So this rho G is common among all the terms, then we can common out. So then what we will get H plus capital H into L1, that's equals to H minus small h into L2, that's equals to H into L3, that's equals to H plus H cos theta into L4. So by equating any of these two, if you calculate the H, if you got the H value is approximately 76 centimeter, then Boyle's law is said to be verified. Because atmospheric pressure is constant. Atmospheric pressure is constant. The average value of atmospheric pressure is 76 centimeter of mercury column. Equate either these two can be equated, or these two can be equated, or these two, any two can be equated, and you can calculate by knowing the values of L1 and L2 H value. If you calculate the capital H value, if the capital H value is a bit close to the 76 centimeter, then the Boyle's law is said to be verified because because the average atmospheric pressure is 76 centimeter of mercury column. So this is the way to verify the Boyle's law by using equilibrium experiment. Actually, it was not there in NCERT, but objective numericals was there when the glass capillary is kept like this. So that's why better to have an idea about the concept. That's why we have gone to the concept. Got it, students?
What's the value of M?
Which one? Mass. Mass value you can equate it to capital H.
So the first case and second case.
Which one? Mass. Here mass equal to density into volume. No, density of the mercury into volume means what can I write? Area into length of this mercury column. That replaces that mass. So here this glass capillary tube is fixed to the meter scale. Thereby we can calculate the length of this mercury column, and thereby we can calculate the length of the air column which was trapped here. That can be calculated. So got it, students? Online diploma. Students.
Yes, sir.
Yeah. First write case 1 then. First write case 1. Then first case 1, case 2, case 3, case 4. At last we can give the conclusion of it. Case 1.
So case 4 is not visible, set on the camera.
First, having completed these first three cases, then we
Sir,
will
1 minute, sir. We'll write then you can.
first write this case one case. Is this finished? Case one, case two, case three. Case one completed, Amma.
Yes, sir.
Case 1 completed.
Yeah. Case two, case three, case four also. Okay, no problem. Hmm? So right, we can copy this. Equations, either of the equation we can calculate which value. Okay. At last we can write this. So with this, the Boyle's law, gas laws are completed. Completed, huh? So we can
1 minute, sir.
yeah. Last step we can write.
Yes, sir, completed.
So equating any two quantities or any two of the above, equating any two of the above, atmospheric pressure, H, capital H, atmospheric pressure, capital H can be calculated. Atmospheric pressure, capital H can be calculated. So this is about the Boyle's law verification by twin tube. Almost whatever the problem they have given based on this twin tube, we can solve it by using this concept. Boyle's law twin tube. One of the experiment it is earlier, now it is not there in the syllabus. But in objective point of view, JEE point of view, there may be a chance to getting the questions in objective point of view. That's why we have discussed that. So next, we keep submitting, guys. Transmission of heat. Okay, transmission of heat. Transmission of heat. So what is mean by heat transmission means so why the handles of the cooking vessels provided with either plastic or wood? Why not they can
Sir, they are good insulators of heat.
no, insulators, conductor, ladder we can okay, ladder we can no problem. Okay, and a wooden chair is there and a metal chair is there. Both are exposed to the same atmosphere. Same atmosphere. If on if we are which one we can feel more cold either when we touch the wooden chair or when we touch the metal chair.
Metal chairs, sir.
Metal chair. Both are exposed to the same atmosphere. Next one is rice can be cooked in vessel. Rice can be cooked in vessel. Whether it is completed or not, we can touch the rice particle. In the similar way, we can't touch the vessel also. Have you noticed that? We can touch the rice and we can keep it at least one piece from it and we can examine that whether it is not completely cooked or not. At the same time, we can't touch the vessel on which the rice is being cooked. So I think you noticed that it is seems to be more hotter than rice. But actually, we have supplied the same heat to the rice as well as vessel also. So what are the why all these one? Why we can't mean cooking vessels are provided with wooden and plastic handling means prevent the heat. To prevent the heat. And similarly, why it is say metal chair is on touching the metal chair, we feel more cold means what is the reason? Even the both are exposed to the atmosphere means. So on we are touching the metal, heat transfer will be more. So on we are touching the metal, large amount of the heat will be flown from our body to the metal chair. That's why we feel more cold. And on touching the wooden chair, of course, heat will flow, but not as much in when compared to the metal chair. The reason is that wood is a bad conductor of heat, metal is a good conductor of heat. Similarly, on touching the rice also with our fingers, it's not too hot. We can one piece of rice can be taken out by our fingers, and we can examine that whether it is cooking process is completed or not. But we can't touch the vessel. Why? Because means the material of the rice is a bad conductor of heat, and the material of the vessel is a good conductor of heat. On touching the vessel, more amount of the heat will be enter into our body in a less interval of time. That's why it is seems to be harmful to us. Next, similarly, on touching the rice, okay, of course, even though both are at same temperature, rice is a bad conductor of heat. So that on touching the rice particle, less amount of heat is entering into our body in a short interval of time. So from all these examples, what we can consider that heat will flow from one place to another place. Heat can be conducted. So what is our discussion mean? Heat transfer of heat. In what way heat can be conducted means mainly there are three ways are there to transfer the heat from one place to another place. One is conduction. One is conduction. Second one is convection. Third one is
Radiation.
radiation. Okay. So these are the three ways are there to conduct the heat from one place to another place. Earlier we have discussed about some examples also whether the heat is flown from one to another means definitely heat is flown from one to another. If the heat does not flow means we need not to provide any wooden handles. We need not to prepare the handles with wood or plastic cooking vessel as we can observe the pressure cooker handle is provided with some kind of plastic. Have you seen that? Okay, the reason is that to prevent the heat flow, And similarly, when we are cooking, you can examine that when we are cooking with a steel, what is that spoon? Keep the steel spoon inside the item and leave it. Then after that, if you are able to touch, means it can't. It seems to be too hard. The reason is that till up to the instant when from the instant when we left till the instant when we are going to again hold it, the heat will be transferred from the vessel to the spoon. So that's why the temperature of the spoon is increases. So that's why it seems to be too hot on touching after the time when we left. So all these examples, all these are concludes that heat will be flown from one place to another place. Okay, under suitable condition. Let us discuss about what are the conditions to have the heat flow from one place to another place. First, in what way the heat can be flown means heat can flow between the 2 points or 2 places, either maybe a process of conduction or maybe due to the process of convection or maybe due to the process of radiation. Sometimes maybe due to the any of the 2 processes, sometimes maybe all these 3 processes also it might be possible. So these are the conductions. First our topic is conduction. What is mean by conduction means the process of transferring the heat from one place to another place, without movement of the particles of the medium. Without movement of the particles of the medium, if the heat energy is transferred from one part to another part, such type of heat transfer is known as conduction. That is called conduction. Next, convection is it is the process of transferring the heat from one place to another place due to the movement of the particles of the medium. The particles of the medium, that is known as convection. The process of transferring the heat from one place to another place without the necessity of the medium. The medium is not at all required. So, on such case, it can be processed to the radiation. So, conduction will take place mostly in solids. Convection and radiation mostly will take place in fluids. Radiation anyway does not require the medium. If the medium is there or not there, by the radiation energy, heat energy can be flown. So convection means how the water can boil. Already we have discussed about anomalous expansion of water. So how the water can be boiled. Hot water will come to surface of the vessel. From surface onwards, cold water will go down. There the water is boiling because of the circulating of the water molecule inside there. There the energy is transferred due to the movement of the water molecule or the movement of the molecules of the medium. That process is known as convection. And the process of transferring the heat without the necessity of the medium, that is known as convection. Convection is mainly happened in solids. Solids means already we know that how the solid is formed. Solid is formed due to the regular arrangement of atoms, and the atoms are then fixed to their relative positions. Just they can vibrate, but they can't. They can't leave their positions. When they can leave their position means when the phase of the matter is changed from one state to another state, then only the molecule leave their position and came out so that the solid gets melted into liquid, liquid gets melted into gas. So, but in if it is a solid means solid atoms are fixed to their lattice position. Without the movement of the atoms, only energy is transferred from one part to another part. Such a process of transmission of heat is known as conduction. Next one is convection. Next, radiation means medium is not at all required. If the medium is required, means we won't get the sunlight from sun to the surface. Why? Because means few kilometers above above the earth there is an atmosphere. Beyond that there is nothing else. There is just a empty space, that is vacuum is there. So if the radiation also should need the medium, means we won't get the sunlight. We won't survive also in the day-to-day life. I think without having the sun, is it possible? Okay, some of them, some of the creatures are directly dependent upon the sun, and other people like us, we are partially dependent on the sun. Partially in the sense, you know that what we need generally we need for our food, and food can be from the sunlight. If the sunlight is not there, plants cannot grow properly. If the plants are not there, means nothing is there. So that's why radiation is the, if the radiation needs medium, means we don't have a discussion also like this. Okay, we won't be here to discuss these things. So that's why radiation does not require the medium, and convection require the medium. In case of convection, molecules of the medium does not move. Only heat energy will be transferred due to the vibrations of the molecules. But in case of convection, molecules they can move randomly in the medium so that the heat will be transferred. So this is about the conduction and convection. So first, note down this point. Got the students got it? What is the meaning of the conduction and convection? You know, online people.
Yes, sir.
Yeah. So keep separating the transmission of heat. First, note down it. Heat can be transferred by the process. Heat can be transferred by the process. You can write first conduction. Heat can be transferred by the process. First one conduction. Second one convection. Second one convection. Third one radiation. Third one radiation. Okay, radiation. Radiation. So then first keep subheading conduction, then we can go for conduction, then after we can go for the remaining conduction. It is the process of transferring the heat. It is the process of transferring the heat. It is the process of transferring the heat from one place to another place. From one place to another place. From one place to another place without the movement of particles in the medium. Without the movement of particles in the medium. Without the movement of the particles in the medium. Without the movement of the particles in the medium. Okay. So next, write 1 or 2 points regarding this. The process conduction held in solids. the process conduction held in solids. So therefore, here on essential point, we have discussed that what causes the flow of heat. No.
Difference in temperature.
Yes. Difference in temperature. Generally, wind is flowing now. Generally, have you noticed that wind flow when we are while walking on the in the outer space? So, wind is flowing means what causes the flow of wind? How the wind will flow? Wind will flow due to the variation of the pressure in the places. Wind will always flow from high pressure region to low pressure region. Similarly, current is also there. In lower classes, you have studied that current. So voltage difference, that is nothing but potential difference can cause the current. That's why you can observe the electric pole. There will be four lines are there. On that four lane, one is called earth. Earth that will be at 0 volt. Okay. So potential difference how causes the flow of current between the 2 points. Pressure difference can cause us the flow of the fluid like wind between the two regions. Similarly, temperature difference can cause the flow of heat between the 2 points. So hence these three are all analogous quantities. So temperature, make a note of that point, then we will leave. Temperature, there exists a temperature difference between the 2 points. There exists a temperature difference between the 2 points to have the flow of heat between them. There exists a temperature difference between the 2 points to have flow of heat between them. Okay, to have flow of heat between them. So right, guys. So see you on next class. That's enough for almost time. That is waiting. So have you got it? Any doubts on that?
No, sir.
No doubt, sir.
Yeah. So see you on tomorrow.
No doubt, sir.
Yeah.
No doubt, sir. Thank you, sir. Bye.
Thank you, sir. Bye,
Thank
sir.
you, sir.
Yeah. Right. Okay. No.
1.